Hi students, hope you're all safe and healthy, and I'm sure you're all enjoying the quarantine period at home, happily eating, sleeping, and doing whatever you want. Now it's time to get back to studies. Our school has started the online classes, so you'll be receiving videos every week, and I request you to spend time in listening to all the videos, taking down notes, and to have a proper understanding. You can very well ask doubts to the teachers, to the respective teachers, and your doubts will definitely be clarified. So welcome back to the world of physics. Hope you remember me. And we had few classes before the lockdown, and we discussed chapter 1 in your book. The name of the chapter is Force. Chapter 1 had 3 sessions, 1A, 1B, and 1C. We completed discussing chapter 1A and 1B. Only section that we have to discuss about is 1C. So before we could go into 1C, I felt it would be better if we have a small recap of 1A and B. I mean, the topics which were discussed earlier in the class. Okay, as the slide insists, the name of the chapter is Force. What is force? Any push or pull is what you call it as a force. When a force is applied on an object or a body, the body can either be a rigid one or a non-rigid body. So when you apply force on a body, there are certain changes that takes place in the body. When you apply force on a rigid body, there can only be change in the motion. Maybe it could be at rest and it starts moving, or it's moving and it will come back to rest. And if you are applying the force on a non-rigid body, there are possibility for other changes, like the change in shape, change in size, and the change in motion. So this is all about force, and you've learned all these in your 9th standard. What's new here in 10th standard is we are going to learn about the types of motion. The 2 major types of motion which we will be discussing in this chapter is linear or translatory motion and rotational motion. What is linear or translatory motion? When the object is moving in a straight path in the direction of force, you call it as a linear or translatory motion. If a body is pivoted at a point, or if it is fixed at a point and you are applying a force, there is a turning effect that happens on the object, and this motion is what you call it as a rotational motion. And then we discussed about torque. The word torque means moment of force, or otherwise you can call it as the turning effect. So this turning effect, moment of force, torque, everything comes under the rotational motion. So this torque is due to the force that you are applying on an object which is fixed at a point. So what are the factors that can affect a torque? The factors that can affect the turning of a body are the magnitude of the force applied and the perpendicular distance from the point that is fixed to the point of application of force. Hope you remember the example that I gave you with the help of a door. And then, how is this moment of force measured, or the measurement of moment of force? The moment of force is equal to the product of the magnitude of the force and the perpendicular distance of the line of action of force from the axis of rotation. I'll repeat it. The moment of force or torque is equal to the product of the magnitude of the force and the perpendicular distance of the line of action of force from the axis of rotation. So it is nothing but the force into perpendicular distance. What is the unit of force? It's Newton. So when you are multiplying force and distance, the unit naturally becomes Newton meter. So the other possible units for torque are dyne centimeter, kgf meter. And what we saw some examples for moment of force, like clockwise moment and anti-clockwise moment and all. and with the help of a door. Now, moving on to the next topic, couple. Couple, the word insists or the word itself says it involves two, the number two. So, couple is a pair of force. So, this pair of force together helps an object to turn in a circular or rotatory form, and that is what you call it as a couple. And the formula to calculate the couple, the moment of couple, is either force into perpendicular distance between the two forces. So it's very similar to that of a torque, whereas in torque it is a perpendicular distance between the point of application of force and the fixed point, or you can call it as the axis of rotation. Axis of rotation to the point of application of force is the perpendicular distance. But here it is the perpendicular distance between the two forces. So it is, if you are holding a steering wheel, then the distance between both your hands become the perpendicular distance between the two forces. Okay. And then moving on to the next one, examples of couple. I gave you quite a lot of examples, like opening a bottle cap, rotating or turning a steering wheel, turning a key in a lock, turning a water tap. All these are examples for couple. And then we moved on to the next topic, equilibrium. When I say equilibrium, what does the word mean? It means when a number of forces acting on a body produce no change in its state of rest or of linear or rotatory motion, the body is said to be in equilibrium. I gave you an example, like you're walking. As you walk, the wind blows at you, but still the wind has no effect on your walking. It does not affect you in any way, which means you are in equilibrium. There is a leaf, or imagine a huge mountain. No matter how much rain falls on it, or how many stones you throw on it, and how much wind blows on it, the mountain is not going to move at all, which means the mountain is at equilibrium. No matter how many forces act on a body, the body continues to be in the state of rest, or it continues to be in its state of motion, then the body is said to be in equilibrium. So there are two types of equilibrium. One is dynamic equilibrium and the other is static equilibrium. Static equilibrium is no matter how many forces act on a body, the body remains to be in the state of rest. Dynamic equilibrium is no matter how many forces act on the body continues to be in the state of motion. So these are the two types of equilibrium, static and dynamic equilibrium. And then moving on to principle of moment. According to the principle of moment, in equilibrium, the sum of the clockwise moment is equal to the sum of the anti-clockwise moment. For this, I remember explaining you by keeping a meter scale on a knife edge and putting some weights on both the sides. When you balance it properly, the scale will come to an equilibrium position. So this equilibrium position is based on where you are putting the weight and what amount of weight you are using it. So this is all about torque, couple and principle of moment. And then we learnt about center of gravity. And as the words that are in the slide says, it is a point where the entire weight of the body acts on. That's what we call it as the center of gravity. And hope you remember that I made you all balance your notebook in single finger. So the point at which you are able to balance that notebook is the center of gravity, the point of center of gravity of the object, because the entire weight of the object acts on that particular point. I'll read out the definition for center of gravity. The center of gravity of a body is the point about which the algebraic sum of the moments of weight of all the particles constituting the body is zero. Or you can say in short, the entire weight of a body can be considered to act at this point. And this point is what you call it as the center of gravity of a body. And then we discussed and we drew pictures about the center of gravity of certain geometrical shapes. And it is nothing but the point falls in the geometrical center of that particular object based on its shape and size. At last, we discussed about how to find the center of gravity of a irregular shape. So I told you about two ways by which we can calculate the center of gravity of an irregular shape. One is, so when you try to balance it on a nail, that object should be able to balance at one particular point, and that particular point would be the center of gravity of that particular irregular shape. Or the other way is, we will have to make three holes, and each hole has to be used to suspend that particular lamina on a stand, and we will draw a straight line with the help of a plumb line. When I told about plumb line, I told you it is used in a construction site. And from each hole, we will have three different lines. The point at which the three different lines coincide, is the point where the center of gravity of that irregular shaped lamina is found. So far, we have completed 1A and 1B, which means the recap is over. Now moving on to the new portion. So moving on to the new topic. The new topic is uniform circular motion. So what is uniform circular motion? When a particle moves with a constant speed in a circular path, its motion is said to be the uniform circular motion. So just try to understand the definition properly. When a particle moves in a constant speed in a circular path, then it is a uniform circular motion. So we have two important words: constant speed, circular path. So before we could understand the definition more clearly, we will try to understand the words that are there in front of you: circular motion, speed, velocity, acceleration, and then we will try to understand uniform circular motion. What is a circular motion? If an object is taking a circular path, we call it as a circular motion. The example is right in front of you. The car is taking a circular path. What is speed? Okay, the distance traveled by the particle at a particular time period. For example, the distance traveled per hour is what we call it as speed. What is velocity? Again, that also sounds very similar, right? That is also the distance traveled in a particular time. But there is a huge difference between speed and velocity. Speed is a scalar quantity, whereas velocity is a vector quantity. Speed only involves magnitude. Velocity involves magnitude and direction. What is acceleration? Whenever there is a change in velocity or whenever there is a change in speed, we call it as a acceleration. Now, when I read the definition, it is when a particle moves with a constant speed in a circular path, then its motion is said to be a uniform circular motion. It is not the particle is moving with a constant velocity. It is moving with a constant speed in a circular path. What do you mean by constant speed in a circular path? Which means its velocity is not uniform. There is a change in velocity. The object is of course moving in a circular path, but it is not moving in a constant velocity. It is moving in a constant speed, but not in a constant velocity. How? So here the direction comes into action. When the object is taking a circular path, what happens? The direction keeps on changing every instant. Every second, the direction changes. It is not going in a straight line. The direction keeps on changing, whether it is turning clockwise or anti-clockwise, the direction keeps on changing. So when there is a change in direction, you cannot call it as a constant velocity. It is in constant speed, but a change in velocity. A change in velocity is what we call it as acceleration. So I'll repeat. When a particle moves with a constant speed in a circular path, its motion is said to be a uniform circular motion. So the speed of the particle is uniform, but the direction of motion of the particle keeps on changing, which means its velocity is changing. So it is not a unaccelerated motion, it is an accelerated motion. So, this accelerated motion of a particle which is moving in a circular path is what we call it as a uniform circular motion. What is uniform linear motion and what is uniform circular motion? If it is a uniform linear motion, when an object is going in a straight line, it has constant speed, it has constant velocity because there is no change in direction. When the velocity is constant, there is no acceleration. It is an unaccelerated motion. Whereas in the case of uniform circular motion, the speed is of course constant, but the velocity keeps changing because there is a change in direction. The object tries to move in a circular path, not in a straight line. So when it moves in a circular path, it means that there is a constant change in direction. Whenever there is a change in direction, you call it as acceleration. So uniform linear motion is an unaccelerated motion, whereas uniform circular motion is an accelerated motion. Hope you understood what is uniform circular motion. Now, when I say there is an acceleration involved, so I don't mind telling it again for you. What is a uniform circular motion is? Object is moving in a constant speed, but its direction keeps changing, which means the velocity keeps changing, and so we call it as an accelerated motion. Imagine a ball rolling. Suddenly the ball starts to roll even faster. When the ball starts to roll faster, you know that there is some force involved, and that is why the velocity of the ball has increased or the velocity of the ball has decreased. There cannot be any acceleration without a force involved in it. So, uniform circular motion is an accelerated motion. So, when there is an acceleration, there has to be some force involved in it. What is that force that is involved in the uniform acceleration? And that is what we call it as the centripetal force. So, it is because of the centripetal force, or meaning of the centripetal is center seeking force. It is the center seeking force which makes the object to go in a circular path. Without this force, the object cannot take a circular path. It will just take away its direction and go in a linear path. So you need a centripetal force to have a uniform circular motion. So what is the centripetal force? It is nothing but a center seeking force which holds the direction of the object in a circular path. So as you know, you might have played this when you are playing like this with your friends. Imagine you are the pink one. So when you are spinning around, for you, the person who is in front of you seems to be at rest, right? And number two, when you both hold your hands and spin around, you will be experiencing two forces. One force is holding you both together, and the other force is trying to separate you. You will feel as if you are going to fly away and fall somewhere far away. What is that force called? You know, according to Newton's third law, for every action there is an equal and opposite reaction. So we have a force called centripetal force, and this centripetal force is helping to move an object in a circular path, and this force is acting inward. When this force is possible, there has to be an opposite force according to Newton's third law. So now you can see this object going around in a circular path, and it is connected to the center with the help of a string, and this string experiences a centripetal force which is acting inward or towards the center. So when I say towards the center, there has to be a force that is acting away from the center, and this is the third law of Newton. For every action there is an equal and opposite reaction. So what happens here? This center seeking force is what we call it as a centripetal force, and the force that is acting exactly opposite to that of the centripetal force is what we call it as the centrifugal force. They both have the same magnitude. For example, centripetal force is 10 Newton, centrifugal force will also be 10 Newton, except that the directions are different. They are equal in magnitude but opposite in direction. This is just the reaction to that of the centripetal force in the string. So, is this centrifugal force true? It is something that we experience. In the previous slide, I showed you two people spinning around. When you are spinning around with a friend, you would experience as if you are going to fall apart. That is what is called as a centrifugal force. The hands holding together and keeping you together is the centripetal force. Well, is this centrifugal force real? No, it's not actually real. It is an imaginary force, or you call it as a fictional force, or you can also call it as an apparent force. It is just what we feel, and it does not exist in reality. Why do we feel that? When it is not real, why do we feel it? We feel it because every object tends to move in a straight direction. So it loves to go in a straight path, but it is restricted to a circular path. So there is something called inertia which we have learned. What is inertia? An object which does not want to change its state of being is what we call it as inertia. So this object does not want to change its state of being. So it is also called as the result of inertia. So centrifugal force is an imaginary force. It acts opposite to that of the centripetal force. It has same magnitude of the centripetal force but direction opposite to that of the centripetal force. And it is also a apparent force. It is because of the result of inertia of the object. Hope you understood what is centripetal force and centrifugal force now. Imagine that you are the pink person and there is somebody, a third friend of yours is standing outside and looking at you both spinning around. According to the person who is standing outside, you both are taking a circular path. But to you both are not taking a circular path. When the pink one looks at the green one, it looks as if the green one is at rest. So there is something called frame of reference, where you are, where you place yourself in the particular situation. So the one who is standing outside will see only the circular path, but only the people who are involved, the green and the pink alone, can feel the or experience the centripetal and the centrifugal forces, not the people who are outside. Okay, now we'll learn more about centrifugal force. What is centrifugal force? The force that is acting on a body and trying to take the body away from the circular path is what we call it as a centrifugal force. It's an imaginary force and it is because of the inertia, or you can say it is the result of inertia of the object. Well, next thing we have to see is, you could see an object going around. If you happen to cut the string at any point, do you think the object would take a circular path after that? No. The object will always tend to take a straight line. This straight line, whenever, maybe you would have learned in mathematics, you put a circle and you draw a straight line from any corner of the circle, you call that as a tangent of the circle. So when the circular motion is disturbed, the object will tend to take a path that is tangential to its circular path. As a conclusion, I would like to say, centrifugal force does not exist. It is the centripetal force that is real and that makes the object to go in a circular path. Here, the tension of the string is the centripetal force. But this centrifugal force just helps us to understand certain things and nothing more. So, So far we learnt about uniform circular motion. What is uniform circular motion? And I told you what is centripetal force and what is centrifugal force, and how the direction changes once the circular path is disturbed. It takes a tangential path or a linear path and the object moves on. And I also told you about the frame of reference. Where you are is called as the frame of reference, with which this chapter comes to an end. We will not be able to discuss the problems now, but there will be time where we will be put in a classroom again and we will be concentrating more on problems at that time. And now I request you not to waste your time. Go through the notes that you've taken earlier and listen to the video again if necessary. Take proper notes and go through the notes again and again. If you have any doubts, you can very well call me or text me or WhatsApp me and clarify your doubts whenever you want, and your doubts will be clarified. This book is not available in the PDF form. If it's possible for you to get the book from your seniors, it would be better. Or the unrevised version, 2013 revised version is in the online, a PDF format. So you can download that. There are some excluded portions. You can just read out only the topics that which we have discussed in lesson number 1 and just leave out all the other topics. Okay, children, do well, try to understand, and we'll get back to you in the next video. Thank you.